All right, this problem says use the description of the pair of lines given below to find the slopes of line 1 and line 2. Now the slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where x sub 1, y sub 1, and x sub 2, y sub 2 are any 2 points on your line. So when I'm looking over here, I'm going to see this first point as my x sub 1, y sub 1, and then the next point as x sub 2, y sub 2, because that's how ordered pairs work. So when I'm looking at this, here's my y sub 2, here's y sub 2, that would be the negative 8. And then here's my y sub 1, this is y sub 1, which would be that 4. And x sub 2, here's x sub 2, which would be that 3. And last is x sub 1, here's x sub 1, which would be that 0. So for my first line, I'm going to plug all those numbers in. So the yellow is here. I'm a color coding fool. Purple goes there, green goes there, and pink goes there, and I just pull out all the numbers. So green was negative 8, and pink was 4, purple was 3, and that was 0. All right, so negative 8 minus 4 is negative 12, and 3 minus 0 is 3, and negative 12 divided by 3 is a negative 4. So the slope of line 1 is negative 4. That's my first answer right there. Now I'm going to do the exact same thing again, except this time with the second pair of numbers. So I'm going to pause for just a second. Okay, so for line 2, I'll do all this in blue, but I'm still looking at, let's see, green, y sub 2, that would be 22. And then y sub 1 is pink, that would be the 6. And x sub 2, whoops, x sub 2 is purple, that'd be this 3 right there. And yellow, x sub 1 is the negative 1, so that would be that. All right, so for this one, I'm just going to plug all those numbers in. I'll spare you the colors this time. This is going to be 22 minus, the pink is 6, and then purple is 3, minus, and then the yellow is a negative 1. That one I will highlight. All of negative 1, it's x sub 2 minus x sub 1. X sub 2 was the 3. X sub 1 was a negative 1. So it's 3 minus a negative 1. And whenever you subtract a negative, oops, it's the same thing as adding a positive. Let's see, 22 minus 6, that would be 16. But 3 minus negative 1 is the same as 3 plus 1, which would be a 4. And 16 divided by 4 is positive 4. And that goes right there. Now, they then ask, is the pair of lines parallel, perpendicular, or neither? That's this question right here. They would be neither. Okay. If they're going to be parallel, the lines would have to be the same. They're not. The slopes would have to be the same. And I'm just going to erase all this so I can do a little more explanation here because I've already got my answers. Okay. If they're going to be, let's see this, if they're going to be parallel, parallel lines have to have the exact same slope. So, I don't know what I'm doing that for. Parallel lines would be a line that runs parallel to another line. They would have the same slopes. These are not the same. Negative 4 does not equal positive 4. So they are not parallel. Parallel lines run side by side, so they're sloped the exact same way. Now, for perpendicular lines, if you're doing perpendicular. All right. Perpendicular lines are two lines that cross at a perfect T. They're actually crossing at a 90-degree angle. And the only way to make this happen is if your slopes are opposite reciprocals. For example, reciprocals. Let's say one slope is, let's say that the slope of this line, that's going uphill. Let's say it has a slope of 2/5. Well, this line obviously has to be opposite because this line's going uphill, that's positive. So this one has to be going downhill, that's negative. And then it's going to be the reciprocal of 2/5, that would be 5/2. Well, if I go back to my two slopes, if I had one of them's -4, then the opposite reciprocal would have to be a positive 1/4. It's not, it's a +4. So not only does it have to be opposite signs, but it also has to be reciprocals. So yeah, they're opposite signs, but they're not reciprocals. So therefore, that's a neither. So hopefully that explains that problem for you and gives you more insight on parallel and perpendicular.